Guys, welcome back to my YouTube channel. Today we'll be dealing with strength of material. I want us to solve direct stresses, right? I want us to put application on what we have learned. This is strength N5, right? Or if you have not subscribed to my YouTube channel, please please subscribe and click that notification button so that you'll be notified whenever I post a new video. Stay tuned as I'm indulging in this video. So I've given question 2. Question 2 here, starting from question 2. A steel wire with a diameter of 2 millimeter, as you can see, support a mass of 80 kg. Says calculate the stress in megapascal. As you can see there, take note, we have given what? A diameter of 2 millimeter and mass of 8 kg there. They say we should calculate the stress. They want the stress there. So you know what you're supposed to do. We'll use our formula. Okay, the last question is this one. I did not show you guys. Here it's one. Question 7. It will be our last question. So that is what we have given there, which is question 2, right? That is what we're given. So they want, we know that stress, they want stress is equal to force over area, right? We've given, this is force, but we've given the mass, but we know that the force is equal to mg in this case, isn't it? Then we know that we have 80, then we multiply that by 9,81, or we can do it directly, right, if you want. So 80 times 9,81 would be 784,8 Newton. Please, if you're a new student, you're coming from high school, I know when you're doing physics, they say use 9,8. When you arrive at college or engineering course, you don't use 9,8. 9,8 is used for physics. Here we are doing engineering and mechanical. We use 9,81. In every subject will be 9,81. 9,81. Please do not use 9,8 as in your acceleration of gravity. I know they are struggling, those who was starting N4. Yeah, you see, with young, isn't it? They've changed the syllabus, they've changed this phase. They faced N2, N1 to N3. So I know you will struggle, you don't have the background, but those who did N1 to N3 throughout, they have the basics. They know that the role they should multiply by 9,81. So get used to 9,81, because if you forget this one, your answer will be completely different. Do not forget that one. It's fine. This is what we have there. What about the area? Remember, now we have done with that. Now we need what? An area. As you can see, we know that we say we've given diameter. That means the cross section, it's a circle, cross section circle, whereby the area of the circle is pi over 4d squared. And another you have to notice, I know if you are from high school, you're using this r pi squared. This is the one and the same thing. You can use it if you feel comfortable about it, no problem. It's one and the same thing. So, but notice diameter we've given it it's in millimeter there, but supposed to divide that by 1,000. You must know your conversions. You must know how you convert them. You must convert that, divide it by 1,000. Divide these 2 by 1,000. If you divide that 2 by 1,000, your diameter will be, divide this by 1,000 there. If you divide that by 1,000, your diameter will be 0,022, 0,002. So we take note about that. Oh, it's fine. So area will be equal to pi over 4 into 0,002, then you square this like this. Then what will be the diameter? They punch that on your calculator, pi over 4, right, into 0,02, then you square that value, what I got there. Then press engine, it will show many zeros. Press engine to be in scientific. Then I got this to be 3,142 times 10 to the power of minus 3. And then always, hopefully we must know that our final values here in engineering, we round them to 3 decimal places. High school we are using 2 decimal places. Now you must stick to this process here. You are dealing with 3 decimal places. You'll read, unless they've stated otherwise, you'll read. But yeah, that's what it is. So let us calculate our stress. Enough for the stories. Then there we have force 8 like that. Divide by this area that you've just calculated there, which is 3,142 times 10 to the power of minus 6. Then what will be the stress there? Remember, we wanted to calculate the stress 784,8. You take that, you divide that by 3,142 times 10 to the power of minus 6 there. And I'll write this to be in megapascal. Your value will be long. You'll get a value like this. So as I punched in my calculator, I got 4,9 like this. Then we'll have 777. Then we'll have 212, which I stress is measured in what, in Pascal. Then I want this to be in megapascal. If I want this to be in megapascal, I simply divide this by 1 million by 10 to the power of 6, right? If I divide this by 1 million, this will give me, or you can press engine on your calculator, will give you, if you press engine, this will be equals to 249,777 like this. When I convert it, it's something like this, you understand? But however, this represent meg. 10 to the power of 6 is meg, so you must know this will be 249,777 megapascal. So this is what you're supposed to know. Hopefully you understand this. So yeah, this is it, guys. So yeah, then question 2, calculate to the nearest millimeter, nearest, the closest as far as possible, the diameter of the steel. You want the diameter of the steel rod that must carry a tensile load. You have given a tensile load without the stress being more than, you've given the stress there, without the stress being more than, okay, it's fine. So we have tensile stress, which is the same as tensile stress there of 100 kilonewton. And then what we have again, the stress is 90 megapascal. You should calculate the diameter. They want us to calculate the diameter, isn't it? So right, it does calculate. We know that stress, remember, it was a direct, this is in tensile, it's force over area, but the area will find, the diameter will find it here on the area, right? So if I make area the subject of the formula, I will have I will multiply there, then I divide again. Okay, let me just take you step by step. I will have that multiplied by that, have, then I want a by alone, I will divide by, will be f divided by the stress there, our direct stress. So this is what we have. We are given these things, right? So we can simply find the area, then you substitute your things here. Area force is, we say it is 100, we know that is tensile, then we'll say 100 kilonewton times 10 to the power of 3. Then the stress is 90 megapascal, you divide by 90. Megapascal means times 10 to the power of 6, that is megapascal. So let's find the area. Then 100 times 10 to the power of 3 divided by 90 times 10 to the power of 6. What will you have? Then I say shift. I will get these to be 1, 1, 1, 1 in scientific form times 10 to the power of minus 3. Then we know area is measured in that. But now, let us, what about the area? We know area its own. The area is given by pi over 4d squared, but the area we said is equals to that. Then we can find diameter. We can make diameter the subject. We have d squared. If you do math, you multiply by 4 over pi 4, and 4 will cancel pi and pi. Also this side will multiply by 4 over pi. What you do on the left hand side, you also do on the right hand side. So you'll have that to be 1,111 times 10 to the power of minus 3 multiplied by 4 divided this by pi. Then I take the square root both sides to remove the squared there. Then I have d will be simply equals to that. Okay, d, if let me just punch this on the calculator. Let's see what is diameter. Square root fraction, say 1,111 times 10 to the power of minus 3 times 4 divided by pi. They said we should round this to the nearest. This I can say is the nearest what? Okay, it will be 0. When I punch, I get this 0, 0, right? Then 3, 7. Obvious, round it to 3 decimal. This is like this nearest millimeter, isn't it? We know this simply 3 decimal places that we are used to. This is in meter, but if you want this, you want to go to millimeter, we'll multiply this by 1000. Then our diameter will simply equals to, you take that, you say 0,0376, then you multiply that by 1000, right? If you multiply this, will be 37,6 millimeter. The nearest one here, it's our diameter then of this steel, right? So this is how you go about. Then number 4, we've given number 4 now. It says calculate the area in square meter. Obviously it's in square meter, it's measured in square meter either way, yeah, of or in square meters of the surface cover, which the load, we have given the load there. This is for 30 kilonewton, must be distributed so that the pressure will be 300, will be 3000 kilopascal. So there we've given the force, which is equals to 30 kilonewton, isn't it? Then also given the pressure, which is 3000 kilopascal. They want us to calculate, they want the area. They say, okay, what is area then? This is a strictly direct question. It's the simplest question, direct one, without wasting time here. This is simply just direct, guys. It's a direct question. So you know that pressure is equal to force over area, right? We want the area, make area the subject, multiply that. Basically, you divide again by pressure. If you make A the subject, you'll have that force over pressure. So then you substitute your force is 30 times 10 to the power of 3, since it's in kilonewtons, over pressure, which is that times 10. If you like, you can put it directly, because this is kilonewtons. You can take it them directly. Kilos and kilos will cancel. What I'm trying to say, if you don't want to, since even if you can convert, they will still cancel. If you say times 10 to the power of 3, as you can see, the SI units are the same. This and this will cancel. So it's up to you from this one, but you stick to what you know. Then you divide to get your answer. So it's the direct question, this one. Simply direct one. 0.01 centimeter squared. That is your area. It's 18 meters squared. Simply an area. If you want it in scientific, you say shift, you press engine, will be in scientific form. This will be like that. Yeah, that is our area. Done. 5 says determine the diameter of the steel wire needed to lift the load. Of 4 tons. Take a note, this is our load is given in tons. If the maximum stress cannot be 90, if given stress to not be the stress of 90 megapascal, and if given that the force there is what, 4 ton, given 4 ton, number 5 should calculate the diameter. If given the force to be 4 ton, then the stress was 90 megapascal. So you must know ton. You must know what is ton, isn't it? What do you know about ton? What do you know about ton? Remember, ton is equal to 1000 what? 1000 kgs. 1 ton. The proportion 1 ton is equal to 1000 kgs. Must be 1000 kgs. So here we have 4 tons. So this will be 4 times 1000, but will be mass. Then if you want to convert it to be force, you will multiply by 9.81. Hopefully you understand. Okay, let me just do like this. You've given the force in this, but now this will be what, when you multiply, will be in kgs. But now for us to have Newton, we'll multiply this by 9.81. So that will be in what, in Newton. Hopefully you understand this. Okay, 4000 multiplied by 1000. Remember, kgs. Remember, this will be in kg. We strictly will have kgs if you multiply that, and hopefully you understand that. If you multiply that, you will have kgs, because 1 ton is equal to 1000. 1 ton is equal to 1000 kg. You will have, if you multiply the kg, but force is not measured in kgs. Force is measured in Newton. Force is mass multiplied by 9. So you'll multiply by this, the one that is left, 9,81. So then if you multiply now, will be in what? Newton. We'll say 4 times 9,81. Then what you'll get there, your force will be 39240 Newton. Supposed to be Newton. So it's up to you. If you want this to be in kilonewton, will be 39,24 kilonewtons. Either way, so that is what the aim is, to calculate what they wanted. Determine the diameter, is to calculate the diameter. So the process is supposed to take, we know that stress is equals to force over area. I make area the subject, will be F over that. Then I can substitute what we have now. We have the force, and then also this is in megapascal, so I can substitute the force. Can take that one as it is, 93. It's 93240 over, this is what it's in 90 megapascal. 90 megapascal is times 10 to the power of 3. Then yeah, I will get the area there. If you punch this, what is gonna be the areas? If I punch that, 39240 times 10 to the power of 6. Oh, not 3. What is this? 6. Remember, why I wrote 3 instead. I'm keeping say to the power of 6, but I'm writing 3 there. Sorry guys, it's meg. So your area will simply equal to 0,000436 meter squared. If you want this, you can write it in scientific to be 436 times 10 to the minus of 6 meter squared. But they said they want diameter. We know that the area is pi over 4 d squared to 436 times 10 to the minus that. Then I make diameter the subject. If you make the diameter the subject, both sides will multiply by, I will divide by this both side, or I will multiply by 4 over pi both sides. This will cancel with 4, pi will cancel with pi. Then what I do on the left hand side, I'll also do on the right hand side. I'll multiply this by 4 over pi, right? Then this side will remain with d squared, isn't it? That one is simply 436 times 10 to the minus 6 multiplied by 4 over pi. Take the square root both sides. If you take the square root, this and this cancel, have a d. This is simply 36. Actually just punch that on the top. Square root, simply punch this quickly. Then we find, let us find our value. Then we have 4 3 6 is 6 or 6. Oh, fine. 36 times 10 to the minus, check, times 10 to the minus of 6 there, times 10 to the negative, to raise to the negatives of 6 multiplied by 4 divide that by what? By pi. All over this is under the square root, isn't it? So you will get this, round this to your nearest. If you round this, you'll get this to be 0, 0, 2, 3, or 3, 3, it's correct. Then I round that to the 3 decimal. I can say you can say 6. Then this is in mid. So 0, 0,0236 times 10 times 1000. If I want this to be millimeter, they say it actual, that is the diameter, needed. Yeah, that is the diameter. It's up to you, leave it where, but that is it in meter. If you want it in millimeter, multiply by 1000 will be 23.6 millimeter. If you round it to the nearest, you take this 3 decimal, you will strictly have exactly approximately to 23 exactly, which is not a problem. We are still okay. No, will be approximately 24. If you take that, if you round it off to the 3 decimal direct, that will be approximately to 24 millimeter. Will be approximately to 24. So yeah, we don't have question 6. Okay, no problem. Let's check question 7. I wonder why I don't see question 6. So it's not my problem. Oh, I've did question 6 is the one that I've did it separately. No, question 8. I've done question 6. I remember separately. You see, I have question 5. Supposed to have question 6, but I forgot that I've did question 6 when I was explaining. Check that video, there is there. So we've given figure 7. 1,9 shows the rectangular bar 4 millimeter wide and 20 millimeter thick, with 2 semicircular holes of 10. You see, I'm a semicircle, it's a half circle, each mentioned across its width. They've tell us across its width. They affected the width, the thickness, which is the width of what they are talking. Calculate the force that acts on the bar if the maximum cannot be that. It's fine. We have given, as you can see, we want to calculate the force. We want this force, the tensile. We've given the stress, which is beautiful. So it's beautiful area. Now what will be area? I want to discuss about you. Remember, this force is acting here. We're focusing on this is the direct stress. We're focusing on the cross section. So suppose you can construct, if you are here and then you look at that, you look that view. If you did drawing, you're supposed to see that view. You'll have something like this there. You understand? You will see a rectangle like this. However, these holes here on the top, there are holes there. Do you see those holes? There are holes. There are holes there on the top. So if you're doing drawing, you see those holes will affect what? There are holes, as you can see. their holes. You're supposed to, you'll see something like hidden details that will show there. You understand? You will see a hidden detail like this. You see something like hidden detail also on the bottom like that. So this thing is affecting the width. Good. So I've explained this is affecting the width. It's affecting the width. It's affecting the width. Yeah. Across its width. Even here they've told us across its width. It's affecting the width. I think previously I've explained this incorrect, but yeah, if I'm checking, if you're looking at this cross section, you'll see that then here we'll have a hidden details. Here will be hidden details. I can make them bold. As you can see there. So what will be the area there? If you want the area of that, we take what is constant, what is not affected there. You understand? We take what is not affected. That is what you check on. What is that is not affected? So what is affected there? The width. The width is not affected. The thickness is the one that is affected. As you can check, these are holes. I want this cross section now. Remember those. When I've sectioned, I want this area where I've cross sectioned. But however, the thickness, yeah, I'm correct. The thickness will be affected. You see, there's hole there now. We simply have in this gap, like we have some hole here. This is a hole. We have affected the thickness. The thickness is affected. We're having a hole. So the area there, if you take what is constant, the thickness will be affected, which is will have a width multiplied by the thickness. You minus what is affecting remember you minus the size of this hole. But now they said we have two diameters on the top, also on the bottom. So we have 1, 2. So this is simply, you see, it's a diameter. 2 is affected by 1, 2. It is affected by 2 semicircle, and then 2 semicircle. When you form 2 semicircle, which are identical forms a diameter circle, which now will be diameter will stay 20. So that is thickness. You'll see here it is 10 multiplied by 2, which will simply 20 millimeter. So that will be 20 millimeter will be minus diameter. This is your formula for calculating an area. You understand? That is our formula for calculating an area. This is what we'll have. So we've given megapascal. They want the force. Okay, they want us to calculate the force. Oh, we want the force. Then we've given the stress there to be 100 megapascal. So these guys, this one is still these are light question, isn't it? Simply light questions. We have question 5. We want the force. We've given the stress to be 100 megapascal. You understand? Here it's our area, will be like that. So stress is equal to force over area. We want the force will make the force the subject. So yeah, let us find the area, because this already we have. There it is. What about the area? We don't know, but the area is that it's equals to width thickness minus diameter. What is our width? We've given the width. Here it's a width. It is 40 millimeter. Then this holes is 10. The diameter of these holes, since we have the radius is 10, the diameter, because there are two, it's on the top and on the bottom, will form up, I have explained, will form up a diameter which will be 20. So here we have 40 of the width, 40 millimeter. So you simply say you divide 40 by 1000 to be in meters. 40 you divide that by 1000, right? So you simply get your 0.04. Then the thickness, what is the thickness? It cannot be 0. The thickness is 20. It's fine. I think here, so I've made a mistake. This thing won't affect the. Sorry guys, sorry. This thing is affecting the weight. Oh, it's affecting the weight. Sorry about this. I'm just realizing as I'm checking the structure. Seems like I'm tired. This thing will affect the weight. Sorry about this. I've explained in the previous video. Will affect the weight. Because here on the top, the weight will be affected. We'll have holes here. There will be holes. Will affect the weight. This thing will affect the weight. Like that will affect the weight. So here, there are holes there. Where I've shaded these holes, will be left with this cross section. So yeah, sorry about that guys. This will affect the weight. Since this is affecting the weight, our area will simply equals to what it will be thickness. What is constant is thickness, which is not affected, width minus diameter. So sorry about that guys. Sorry about that. This thing I'm checking, I just see there that something does not make up. This will affect the weight. If it's affecting the weight, this is how the formula is gonna be. So yeah, so area, the thickness is 20, which is would be 0.02. The width, which is 40 millimeter, which is gonna be 0.04. Diameter will be 20, which is 0.02. Right here will be like this guys. Sorry about that. So yeah, 0.02 into 0.04 minus 0.02. This will simply equals to, in scientific form, 400 times 10 to the minus 6 meter squared. Sorry about that. Yeah, that it is, guys. Then we want the force. You can substitute our things. Force, we have that. It was 100 megapascal times 10. Then we have 4 times 10 to the minus 6. Then we can find the force. Remember, our stress was 100 megapascal. I still remember here it was a stress here. So if you punch that 100 megapascal, right, multiplied by 4 times 10 to the minus 6. This will be strictly 40 kilonewton. I'll write this in newtons. 40 kilonewton. I have converted already. Simply 40 kilonewton is the force that will take place there. Will be 40 kilonewton. This force, this tensile, will be 40 kilonewton. So thank you guys for watching, and thank you, and please do not forget to subscribe to my YouTube channel and click that notification button. You can share this to your fellow classmates. Feel free. Thank you for watching. All the best.